a professional, uh, mm, simple, what was that? A professional meeting, a very short meeting could turn into a good friendship, as well as a good platform where we can exchange and collaborate and learn from each other. Back in 2019, I met Dr. Samia as a substitute for her supervisor, where she was going for one of the lecture at Jamia Millia
As a
Islamia. And
PhD student would sound better,
yeah, at
huh?
that point of time, you were a PhD student. You were finalizing your PhD, and you started with, you were a substitute for your professor at the Center for Innovation and Entrepreneurship. You were where you went there for your Internet of Things lecture, if I'm not wrong. And I was the one coordinating that particular program at that moment at Center for Innovation at Jamia Millia Islamia. That was a very short interaction, and later on, we caught up during the pandemic and after pandemic, where I got to know that Dr. Samia has moved to UK for her postdoctoral fellowship, PDF, where she worked very hard, came up with good publications and so on. And later on, after 2 years, then I got to know that she has joined University of Greenwich as lecturer in UK, London. So that was something that was not just phenomenal from her part, and I was happy being a friend. But moreover, it was something inspirational for me and for others to whom I have shared the story. She continued being a lecturer at University of Greenwich for more than 3 years, I suppose, and now she has joined University of Southampton, Delhi campus. Although she had the offer to join the UK campus, but she wanted to come back to India. So I think this is something which is quite inspirational when coming from Delhi University, UG and PG, and then her PhD from Jamia Millia Islamia. We all can, relate to the success story of Dr. Samia Khan, and I really congratulate her. And it's a very proud moment for us, for me specifically, being a friend to Dr. Samia, and inviting her to take this particular session on leveraging digital communication campaigns for sustainable blue and green economy. So I think as far as the whole profile is concerned and her achievements are concerned, I'll invite Ms. Faizi to come up and share the complete narrative with the participants and the colleagues. Ms. Faizi.
Yes, sir. So, good evening to all present here. I'm Faizi Khan, a PhD scholar at Jamia Hamdard. It is my privilege to extend a warm welcome to everyone gathered here today. It is an honor to introduce our esteemed guest, Dr. Samia Khan. She is a lecturer in computer science at University of Southampton, New Delhi. Dr. Khan is a distinguished academic with notable expertise in data science, ethical intelligence, and interdisciplinary research. She brings extensive international experience to her work, reflecting a strong commitment to advancing responsible and inclusive technology and development. Her research spans prominent areas such as AI for social good, data feminism, and indigenous data governance. Dr. Khan has delivered several keynotes, addresses, and guest lectures at leading global conferences and prestigious universities. She has also authored, edited significant academic works published by Elsevier and Springer. Prior to her current role, Dr. Khan served as a lecturer at the University of Greenwich, United Kingdom, where she made substantial contributions to curriculum development, student mentorship, and supervision of award-winning undergraduate research projects. She holds a PhD in computer science and has participated in several funded research initiatives focused on artificial intelligence, healthcare analytics, and sustainability. In addition, Dr. Samia Khan is fellow of the Higher Education Academia (HEA) and serves as an active ambassador for women in data science and advocating for diversity, equity, and representation in the technology sector. Now, I would like to ask Dr. Samia Khan to proceed further. Thank you.
Thank you very much for the kind introduction. I hope you can hear me and I hope you can see my screen.
Yes.
Yeah. Okay, so I'll just share my screen. screen. Now, once I share my screen, I won't be able to see, or I mean, I'll be able to hear, but I'll not be able to see. If there are any questions, if there's any comment, any remark, please shout out. So let me just put this into screen sharing. So just a quick sanity check. I hope you can see my screen.
Yes.
Okay. All right. So thank you for the kind introduction. I think you've seen and heard two versions of my introduction. So I'm going to speak about myself a bit. You know, academics like to speak about themselves. So I'll do my talking as well. But to start with, today I am here to talk about. Okay, so I'm here to talk about digital communication and marketing, and how that's basically a brilliant tool for encouraging sustainable blue-green economy, something that's really in fashion these days, not just for business, but also, I believe, for computer scientists and data scientists. So I'm going to try and give you a sort of a mix of data science perspective, computing perspective on things that you already are brilliant at, business. So about me, if I give you my version of my story. So yes, I did an undergraduate and a postgraduate degree from Delhi University, and I went on to do my PhD from Jamia Millia Islamia in computer science. Well, fortunately, unfortunately, India does not have a PhD in data science. So the topic of my research was primarily big data and data science, and leveraging big data frameworks for different kinds of applications. So more of an applied work, I would say. Then after my PhD, straight away, I mean, I got a postdoc opportunity and I went to the UK. Most of my postdoc research is also around using data science for SMEs, how digital adoption is something that can help SMEs, not just tech SMEs, but also SMEs that work in different areas of businesses, and see if this is something that can help them improve in terms of operations, in terms of, because money is all that businesses care about, in terms of money as well. So that's basically what I've done as research. Now, currently, and after that, as researchers intuitively just graduate into becoming academics. So I started as an academic at University of Greenwich, been there, done that for almost 3 years. And I'm back in India after some time, still teaching at a UK university. But most of what I do currently is I'm looking at the undergraduate program in computer science, so teach mostly foundational computer science. My current research and the kind of work that I do now, it has multiple laterals, but I'll only tell you the lateral that I think affects you the most. It is around green computing, so looking at green data centers, looking at how at the very computer science level we can make computer science more sustainable. Because as you would know, and I think there's been a lot of hue and cry about it globally, that computing eats up a lot of our resources. Not just in terms of, using up a lot of electricity, which we obviously do, because as you would know, data centers around the world take up just so much of energy, and that you can gauge that from the fact that there was a time when this was a very popular example that we used to give at conferences, that the amount of energy that's required to run a single AI search that we very popularly do these days using our smartphones, the amount of energy that the background is taken up by the system to do this is equivalent to the amount of energy that would be required to charge your phone from 0 to 100 once. So that's immense amount of energy for a single ChatGPT search, for example. However, companies like Google on its Gemini model, OpenAI on its ChatGPT model, they've been working really, really hard to get the energy levels down. There was a time when most tech companies would not actually tell the kind of energy that their products are consuming. The good and the bad part of moving most things to the cloud and moving data storage as well as moving computing to the cloud is you no longer have a tab on how much energy you're using to accomplish something. So if you're doing it on your system, you can obviously tell, your system is going to burn out, the fan's going to cry for help and your system's going to go down in battery really quickly. But because most of our current systems are mostly hosted remotely on the cloud, it's primarily very difficult to keep a tab on the kinds of energy that go into doing very simplistic stuff like computing or storage, something that we very easily, very conveniently do these days. So posting on Facebook, or like Arisab was saying about posting the video on YouTube. Now this is going to be stored somewhere on one of the data centers, which is going to sit there. Multiple copies of it are going to be available around the world for backup purposes, because you would want to search it from anywhere. And for every single data center, one of the biggest challenges that we have, other than the energy, other than the pure power supply that we require, is every data center needs a cooling mechanism. So there are huge water pipelines that use quality water that run across the data center to cool the data center down, because the amount of heat that's generated by servers, by racks of storages that are kept at every single data center, it's immense. And in order to cool that down, we need very high quality coolant, which in most cases is water, which is used. Now, again, a typical example that's usually given in this respect is the amount of water that you require per hour to cool down a data center. A considerably sized data center is equivalent to the amount of water that you could fill an Olympic-sized pool with. So this is a per hour estimate, and we need to change the water very, very rapidly. So in an age and time where we are challenged in terms of resources, there are countries, I mean, except for most the top league countries, I think most countries struggle with providing their people with power supply, with water, with quality water. Quality water is something that's a considerable issue in the world, throughout the world, I believe. And I can tell you that about the UK as well. So UK has been struggling with quality water issues lately. So it's not that the first world countries are immune from it. So in times like these that are already unprecedented, that are already very challenging, we are coming up with tech, we are coming up with solutions that are raising the bar when it comes to the usage of resources. And sustainability is a considerable question that we have to ask ourselves as computer scientists, me, yes, and as people who sell out stuff, people who market it. I think sustainability should be ingrained into everything when it comes to product development, how that product will be used in the future, and how that product will be marketed as well. So from a business perspective. So because I'm a data scientist, I'm a computer scientist, I'm going to be a little heavy on the data side of things and less on the business side of things, because I assume the people I'm talking to know business better than I do. So I don't think I need to talk to you about business. I'll talk to you about my stuff, data. So from a more generic perspective, I think the one thing that data has done brilliantly is it gives us very solid evidence to say that something is a problem. Right. And so that's a statistician's job. It's to give you data and tell you, well, I think it's a problem because 27% of the times this is going to happen. Or, I mean, it just makes it more credible. So most environmental problems weren't really problems until we had the data. We could collect the data for it. We could process it. We could have insights, and we could make it visible to people that, well, this is the evidence and this is why it's a problem. So data has done that for us. Now, talking about green economy, blue economy, terms that you people own, I think more than me, but I'll just go. I'm just going to randomly use them. So when it comes to sustainability, we start at home. So everything that's inside the home, things like energy usage at the individual level, at the organization level, at the country level as well. Anything related to waste, transport, all of this is largely also a data problem for us and a computing problem for us, because we are supporting with the infrastructure to do all of this. So making sure that everything inside an infrastructure works in an eco-friendly, sustainable manner is everything that will go into green economy, and everything that's outside. So everything related to oceans and rivers and water, like I mentioned, will go into the blue economy side. Now, again, I am going to make a statistician's statement, which is you cannot really manage what you cannot measure. So there has to be a quantitative measure for everything, for proving that something is good, for proving that something is bad. Both of these require a quantitative measure. Now, from a data pipeline perspective, and I'll start with that because, like I said, both green economy or blue economy and the infrastructure that's required to support these two terminologies, these two business jargons, really comes from data-driven systems. So systems that basically work on very naive computer science principles. We collect data using sensors. So if I just take the example of energy in a smart home, let's say, the way that we get to know about, or any energy company comes to know about the usage at home for a single family would be, they put sensors into your meter. Obviously, you've got mobile phones on which you've got apps, and that kind of tracks what are the kinds of equipment that are running at a time, which are not, and what's the kind of per equipment energy that you're using. And all of that put together, all that data collected together, not just at one individual home level, but at a community level, and then at a city level, and then at a country level, all of this citizen data is stored somewhere. So storing is one different story. Like I said, data centers get involved at that point in time because all of that data goes to the cloud. It's not stored on your laptop. It's not stored on your phone. It's not stored anywhere physically around you. It's stored in what we call as the cloud. Now, everything that goes into the cloud obviously is subject to being stored at data centers, and then all of the sustainability issues that plague AI. So we looking at green AI, we looking at green data centers, all of that come into picture from a sustainability perspective, that we need to store all of this data, this data, which is not just small data, but it's a large volume of data, which is coming to us in a variety of forms. And it is coming at a very regular pace. So there's a velocity component associated with it as well. Now, any data that you store anywhere, and social media is a classic example of this, and this is one of the reasons why I'm in job and most data scientists are in job, is the kinds of data that we push to the cloud are different. So as you would have probably seen, that if you try and process a simple text file, how much does that actually is on this? It's probably a few KBs. If it's an image, it would be, well, if you've done it if you've clicked it from a good camera, it might just go to MBs. And if you're talking about a video, that would probably be NGBs, right? So the storage requirements of different kinds of data is different. The processing requirements for every different kind of data are also different. So if I have to process a text file, it's pretty straightforward. It's character by character, parsing of the text, and then trying to make sense out of what's the context and how should I react. Precisely how most of your text-based systems work. So Alexa works that way. Most of your chatbots work that way. So even if they are AI powered, or even if they're not, they're rule-based, all of them purely work in this principle, using the principle that the text is read character by character, and we process it character by character. Now, when it comes to images and videos and audios and the different kinds of other kinds of data that social media brought to our lives, and smartphones contributed heavily into it, is that it's not as easy to process these. So the most naive explanation of this that I can think of probably is that if you look at images, everyone knows that, I think most people do that level of image processing these days, that you would, before you post an image somewhere, you would put a filter, or you would kind of process it, change the way it looks in terms of, whether the background does it have any objects? Can I remove it? You can use AI for most of the things with image processing these days. But the key problem with images is because images are broken down on the basis of the resolution, and something that you would have already seen. In most of your images, it's 1024 by 1024, or bigger sized images. If you resize them, you will probably see exactly the number of pixels that are there. So it'll be some number of pixels multiplied by another number of pixels. Now, what that means mathematically, if I'm trying to store this, it's a huge table that I'm going to write in Excel, which will have 1024 rows and 1024 columns, and I'll have RGB values. RGB is just red, green, blue, the intensity of light value. It's sort of a scale. You don't need to bother much about it. It's just a sort of scale that measures the color at that particular point. Now, how is it that the resolution of these images is better if the pixels are better? Because I mean, the granularity at which you're capturing the intensity levels just increases, and thus the quality of the image also increases. So what I'm trying to store with a very simple image is a huge table in Excel, let's say, right? So image becomes complicated, a little complicated. But with videos are multiple images and thousands of images just put together for some second video, which just increases the number of tables that you're going to store for every single image in the video. And then you have to maintain the chronological ordering of those images as well for the video to make sense. So as we change the data type, the kind of processing requirements change too, and the kind of computing requirements change as well. So while doing a text-based analysis of something would use some computing power, and at the cloud, it will use some computing power, which will take up some energy. The water that's required to cool the data center is going to be common across all, but it's going to use some energy. But if you are doing it for heavier data, if you're doing it for images, if you're doing it for videos, and if you're doing it for a mix of them, so the system first needs to make sense out of your data, understand what's the structure, understand if it's an image or a video or what is it that it should expect, and then process it. The amount of computing complexity of a particular task increases manifold, and the amount of energy that it requires to process it also increases manifold. Now, other issues that we are facing with data centers right now is that this data is continuously evolving, and the amount of data that we're getting, the velocity of data that we're getting is also continuously evolving. The kind of data that we're getting is also evolving. So your healthcare data would not be same as your environment data, and your environment data would not be same as your customer data from, let's say, a retail store. So all of these are different. And so the clean and processing and finding patterns and all of this, all of the computer science side of things, where we're trying to find the algorithmic balance between what is the most optimal way to do a particular thing, all of that also changes. And all the computing complexity and the storage complexity of all of these will also depend on the kind of use case that we have in front of us. So while the first four largely are computer science, the first three are computing heavy, but the last one really is important for people coming from marketing, because it's the insights, it's what the user sees finally. That is the information that you use for marketing purposes, for triggering behavior, for changing the way people act on a particular thing, on influencing decision making. So visualization, which is actually the last part of our data science pipeline, where we try and convert our results into actionable insights for the user, and use all sort of, there are multifaceted and multiple kinds of metrics that are used to understand what is the right kind of visualization technique for a particular use case. And while heat maps might be brilliant for some, there's that's a very simplistic color coding that's used for, let's say, AQI, which is a hot topic in India these days, something that I hear about all the time. But that's basically where our job finishes and your job starts when it comes to converting this set of information, this set of visual information, using it and packaging it in a way that can influence behavior. Now, whether that influence in behavior is to market something, or whether it is to build onto a sustainability campaign, understanding what the problem is, defining how we can modify or alter behavior for good. All of that would actually start and really make sense to you in the last 2 points, which is translating insights into behavior triggering points. So data alone, changes nothing. But when data is converted into actionable insights, and when it's communicated in a way that it should make sense to people, that is where the changes really happen. Now, I've got a few examples here. So most of the places where data science has really hit hard, and I would say that in a positive way, is very simplistic applications that were not thought of. And I think the biggest innovation that computer science does anywhere in the world is looking at the most simplistic of issue and solving it. That's where innovation comes from. And I don't think that's very specific to computer science. I think that holds true for any domain for that matter. But one of the examples that I have here is there's this very naive example of how a data-driven application, not even an application, just a sort of a product can influence the way people do stuff and influence the way their practices can be made more sustainable. So, for example, let's say there's a fisherman in Kerala who blindly fishes, goes out for fish hunting. Now, in such a scenario, I mean, you're wasting on so much of resource. You're not just wasting on time, etc., but you're also wasting on fuel. You can generate much more income in lesser time. So all of this is something that can be triggered by a very simple application, which allows you to allows the person to see a sort of map and understand that today the fishing zone is probably in this colored area, and these are the coordinates. So the person directly needs to go to a particular place and hunt for fishes there. So this just makes the whole it's benefit for all parties, which is important, but it also makes the whole process very sustainable in terms of how much was the carbon emission, if I may say that, and how much was the fuel that was used, what was the time that went into it, what was the income that was finally generated from it, and was the whole process ocean friendly or not. Now, I would really like to relate this to, let's say, Google Maps, which is something that I can't imagine my life without, but I think most people cannot imagine their lives without too as well. So before Google Maps existed, most people used to, you have to remember ways to places, right? And if you did not remember ways to places, you would be given cues in terms of milestones that if once you reach that place, ask somebody and the person might lead you to the next milestone and so on, right? Time consuming, resource consuming, the chances of error are way higher, and fuel consuming as well. Carbon emission, not carbon emission friendly at all. So all of that contributed to a problem that, if you see, has been brilliantly solved by Google Maps, right? So the moment you just tell it where to go, it tells you the best possible route. It also gives you options. It's not that it's going to force you onto a route. So with AI, it's all the more, I would say, personalized. So now it knows the kinds of routes that you would like to take. Also, if you've got a better route and it does not know about it, it can update itself. So it's sort of a feedback from a very computing perspective. It's a sort of feedback loop that comes into play just to make the whole system more eco-friendly, more sustainable. But in the background, again, there are AI models that power all of this, and AI models and making them sustainable is something that's a big research area within the computer science domain, where we are looking at algorithms that can we can reduce the amount of time, the amount of computing resource, and the amount of storage that would be required to complete a particular task. So that's more of an algorithmic research issue within computer science. The other thing, another kind of application that is very useful these days, particularly in the current pollution setup that exists in Delhi. So let's say there's an AQI app. There are, very many. So most people, before they move out, before they go out, I do that myself. So check the AQI. Not that it helps a lot, but I think most people check that. So one of the key visualization strategies that's been used by most of these applications is, and it's not something that that's been an innovation. It's something that has existed with our traffic systems ever since I remember. So anything that goes into the severe zone is red marked. Anything that's sort of okay, moderate, is yellow marked. Anything that's it's okay, you can go sort of marked, it's green. So using very simple color schemes is sort of intrinsically, I would not like to go into the theoretical models of how visualization is designed for applications, but just to make sure that the information is presented in a manner which is actionable, giving an actionable insight out of data. So using colors, using alerts, using very simple instructions to make sure that People get the information that is required, and the information is presented to them in a manner which can trigger behavior change. So the use of information, whether that's chronological ordering of information or whether it's information, purely information itself, putting it together in a sort of a framework that allows people to adjust their behaviors, to make more well-informed decisions, but also from a governance perspective, allows the government to not, I mean, we don't live in times when anything can be enforced, but we live in times where everything, you need to influence people for them to be able to take action onto something. So whether you can influence people into doing something which is a positive behavior, so a positive looped behavior, reinforcing positive habits, which can generically then make an impact on the way the whole story is panning out. So whether, we talk about the COVID times when the whole thing about using masks, not going out, the whole campaign of, ensuring that social distancing is maintained, was largely social media driven. So the whole story around, so largely data science and its models were used to kind of make predictions on what's the sort of transfer rate, whether there are high infection areas that you should be avoiding. Or if I tell you about a project that I was working on at that time, and I was in the UK when COVID happened. So there was this project that we had from a robotics company, and they were looking to design specialized robots that can, because cleaning spaces and cleaning large spaces, like let's say football grounds, football matches weren't happening for a short period of time, but they started to get people back into their normal life and on track very quickly. So cleaning football spaces or big auditoriums or even university spaces for that matter. So closed spaces, open spaces are the two kinds of spaces that they were looking to clean up, sanitize. Now, from a computer science perspective, what that meant was the robot should be able to enter a space, identify high-risk areas, so areas that would require more sanitation than others. So commonly identified areas. We use machine learning, deep learning to identify that sort of a pattern. But door handles, for example, any tables that you could put your hands on, or if there are specific areas that are blockers, so or places where a lot of people might sit together. So identifying all of those and then kind of creating a heat map of where more sanitization is required, and then obviously the usual programming of the robot to go and sanitize the specific spaces based on the red, yellow, green sort of color coding of the heat map of a particular room or a particular space. So color coding is something that's very commonly used in visualization for the ease of users to understand what is the action that they immediately need to take. So adjusting outdoor activity, helping them make better decisions is something that's more of a visualization lookout, and something that's very, I would say, needs to be very cleverly used when it comes to building up campaigns. And from a very product development perspective, we try and take inputs from people who are into engagement activities to understand the market and understand what kind of what would be the psyche or the psychological makeup of the people or the audience that and what is it that what's the kind of behavior that we are trying to enforce onto them. So there are a few more examples that I've got. One is around waste. So from a computer science perspective, again, the data that would be collected in order to understand if there's just too much waste on the beaches. And we can collect that using sensors, we can process it, we can have a sort of color coding of which are the beaches that are, or which areas of particular beaches are waste heavy. But then the kind of response that we are expecting from the general public is we expect them to not do this at those particular areas more, but also not do it in general, right? So it has to be things like public screens, giving them messages on, this is maybe a a waste prone area or whatever, something like that. Just like, traffic signals use it for accident prone. The moment you see an accident prone kind of sign somewhere on the side of the road, you are a bit more careful. It's like playing with the psyche of the people based on, so it's sort of a loop thing where loop thingy in a way that you look at visualization from the perspective of what the users might want to think about it, and will this trigger any sort of emotion in them? Emotion leads to a change in behavior. So that's the sort of cycle that we look at. And a similar thing was this was more of a social experiment that was done by one of the research groups, where they were trying to restrict, as part of the sustainability initiatives of a school in London. They were trying to reduce the amount of plastic bottles, the number of plastic bottles that are used by children for any kind of purposes. So what they, the kind of experiment that they were doing was largely about if somebody was throwing a plastic bottle into the bin, there was a sort of an animation that was playing up. And the way that it triggered behavior in children there was, so if you're putting the plastic bottle in the right bin, it would go into recycling. And that would sort of give them a sort of score in terms of how are you faring in this whole sustainability cycle. That triggers an emotion of achievement, which in turn triggers a change in behavior where people want to feel more of that, and that changes the sustainability story. And it actually did. So there was 57% improvement in the recycling efforts of the school, which were reported. So the sustainability paradox basically is we are using digital tools to save the planet, but digital tools are also using resources from the planet. Now, if electricity is something which is not sustainable and is a problem, and we need to kind of solve the problem using computing resource issues or whatever, I mean, all the kind of research that we do from a green computing perspective, the paradox is that the things that we are trying to implement in order to make a journey sustainable, all of those things also require tools that then again cause a sustainability problem. So we're getting into a sort of vicious circle where we are trying to make it. So, I mean, one of the examples that I can give you for this is I was just speaking to one of the tech leads at a company, and he was telling me about how they don't want to hire programmers anymore. Why? Because programming is something that's more of a very semantic skill, in the sense that ChatGPT can do that for you. It can write brilliant code for you, a code that runs perfectly fine, does the testing for you as well. So he's like, more than 70% of coding is now done by AI for most of my projects, and I am no longer looking for programmers. So because I don't see that as sustainable, in the sense that, I mean, I can hire 2 people. They don't need space, so I don't have to maintain the infrastructure. I don't need to upskill them all the time. They are not going to travel as well to places, etc. So from a very low level perspective, yes, it's sustainable. But using AI for a thing to the level that you are kind of putting 70% of its stakes into AI itself is not sustainable in that way that, like I told you, I mean, every single AI query takes up a hell lot of energy. And all of that energy is complemented with the amount of water resource and everything else that goes into the picture. So while we're trying to work on sustainability at the lower level, we are causing more sustainability issues at the higher level, which is a sort of paradoxical situation that we've landed up in. Now, what I generally work in is mostly around green AI. So making sure that AI models, artificial intelligence models, are smaller in size. They are small. When I say smaller in size, they're lightweight. They are not computing intensive. They are efficient when it comes to both performance and memory, and the computing resources that they're using are renewable as much as they can, as much as it is possible. So there have been multiple efforts in that area around making AI sustainable, or generically making data centers sustainable. A few of them have been around. Data centers are located in EU. Some are in America. So whenever you kind of choose a computing resource online on the cloud, you actually can see which region the cloud resource is located in. Now, there's been a considerable shift in the infrastructural community, in the community that works around hardware and building infrastructural resources to support the kind of computing needs that the world now holds. Because computing needs today are not just limited to social media; they are limited to a lot of other things depend on them as well. For example, the whole of the hospital management system works on the cloud. So if that fails, a lot of things fail. A lot of diagnostic systems are now AI powered, particularly in the first world countries. Most of these, X-ray processing, where they tell you if you've got a fracture or not, is largely AI based. Cancer detection is swiftly converging towards a point where it's going to be very, very AI based. So while most of our critical systems now, transport system, which is one of the most critical systems that we have. If the transport system of a city fails, the whole city comes to a halt, literally. So most of our very critical infrastructure is now swiftly, gradually converging to a point where AI is central to its existence. But what that also means is, if we are going to use AI in that capacity, we will need infrastructure that's sustainable, because we can't afford to, put in the kind of energy that AI requires as we go forward. There was a very popular study around this, which said that if the total amount of energy that the world produces, we are going to kind of outnumber that. So computing, pure computing needs of the world are going to need more power than what the whole world can generate by the year 2037. So we are kind of reaching a point of no return, which is why green AI, green computing, green data centers, all of that has become very, very relevant from a sustainability perspective. The same largely holds true for green computing, and why that should be taken into consideration when it comes to all of this. Now, when it comes to designing campaigns for sustainability, I think one of the key things that we have to keep into consideration is it's not just about the product and how it is going to be used. It's also about what are the laterals. What all is being used in the background. That should also be sustainable. It should not just be product usage that needs to be sustainable, and surely not just about the processes of getting it into the market. Now, to kind of make a closing remark on this, digital sustainability largely sits on the foundation of sustainable digital infrastructure, which is why data science and data-driven computing needs to be sustainable in order for economies, whether green economy or blue economy, to be sustainable. Now, from a campaign perspective, the way that data kind of supports and how it completely fits into the story is data is what can be converted into actionable insights, and actionable insights are what are going to trigger an emotion, and that emotion is what changes behavior. So if we start with, and if we have to design a sustainability campaign, then we start with the data. So data, because data is what detects the invisible. So is there evidence to support that something is going to be more value for money, is going to be more sustainable in a particular perspective? Then digital is what makes it visible, in the sense that if you've got a visualization tool to support it, that is understandable for everyone. From a user perspective, then that digital communication is the second layer of how we put data into perspective. Now, this visualization should be done in such a manner that it triggers an emotion that, you should feel good or bad or angry or unhappy about things. And that is what triggers a change in behavior. Now, once this is done at an individual level, and if we collect enough data to gather insights about how we've been able to modify behavior, that triggers a change in policy. And that's what, in the long term, should support sustainability. So, and this is more of an inspiration. So if you want to build your own data story, start with a problem. See if you can cite a hero there, like the fisher in our case, or a student or a tourist. Look for the data sources. So where all are is the data coming from? What's the digital tool that can be supported with? And what is that gonna? Whether we can come up with a trigger that can a trigger point, which can be a color score or a mapping or a red, blue, green sort of red, yellow, green sort of mapping of what is severe, what's not so severe, what's okay to go ahead with, and what's the kind of behavioral outcome that we're looking at towards the end of it. Data is largely the pebbles. Digital communications is what the ripple that we are looking at, and the ripple that you create at the School of Management is a change in behavior. With that, I would like to close my presentation. So if you've got any questions, I'm happy to answer. Is anyone there?
Yep. So the forum is open for Q&A. Though I have my set of questions, and I always do, but as a coordinator, I'll just sit back for some time and I'll just...
You're an old friend. Ask easy questions.
No, it's that will be easy, of course. For you, that will be very easy, I'm sure.
Okay. All right, go ahead, shoot. But somebody has something in the chat.
No, I was just looking at that. Nobody has any question, but yeah, you are invited to, I know this is evening time and you might not be able to open your mic, so you can post your questions here as well.
I'm happy to be contacted in case you want to collaborate on any sort of front. I'm very happy to send me an email. I'm happy to collaborate.
Yeah, in the meantime, if you're coming up with any query, fine. I have mine, so I'll just come up with mine. So before I go, any further, I just simply like to reiterate what exactly happened yesterday. Yesterday we had Professor K.M. Baharul Islam from IIM Kashipur. He was the one who came up with a very basic idea of portraying sustainability in our daily practices, and his topic was basically on leadership styles and how exactly leadership could come up with the sustainable practices and bringing it in universities like ours. So what he suggested was why can't we simply start with the very basic thing, and we can use the papers which have already been printed from the other side, and we can use it in the billings. We can use it in sharing our TADA forms, and why not for other processes?
Well, the admin people might not accept it.
Yeah, so we have the Sarkari Babus in our office, and they might simply...
But University of Southampton ranks very highly on sustainability globally. But one of the key things that I think almost everyone remarks at is if you're working on sustainability, plastic bottles should not be used for guests.
So yeah, that was a topic yesterday. He was discussing on few of the things like leaving the plastic bottles and having the the glass bottles with us, and then using the other side of the waste papers for regular processes and all those things. So while he was mentioning those things, so somehow somewhere making them understand is something which will come from top to bottom. Maybe the vice chancellor or the registrar of the university will come up with certain circulars, and then they will promote these sustainability practices in the university, so that the Sarkari Babus sitting in those chairs, they might not reject our claim forms. And
but most sustainability practices, I think policy making is towards it's just the last leg of it.
Right.
You have to first implement something, get data around it, and kind of prove that, well, this is working, and get the right boxes ticked off before it converts into a policy.
True.
So I think it starts with an initiative and then finally ends up as a policy.
So I think these institutions who are in their prime, for example, IIMs and IITs and NITs, once they start practicing, and then the universities and the institutes who follow the legacies or the paths that have been carved out by those institutions, these universities and institutions, they also come up with the similar kind of policies and all. But yeah, the leadership is important. However, we as marketeers and those participants, I suppose, those who have joined today, we do understand that there are challenges in maintaining the ecology while we are doing our own businesses, right? But thanks to you for bringing all the, for bringing the information about what, there's a gravity in what we do. If you are picking up a platform, there will be a gravity, there will be consequences. So since you mentioned at the very beginning that, if you can't measure, we can't manage. And that's one very good thing that I appreciate. So what suggestions do you have for the marketeers, for people who are into the field of management? How exactly we should look at the marketing activity? Whenever, let's say I'm trying to post something on, digital platform, maybe over LinkedIn, social media, and any other places, that we as marketeers might be a bit greedy. We as marketeers might be a bit ignorant about the final consequences. But the moment you mention, people from your field mention that yes, there is, some measurable item or some measurable carbon credits are attached to it. So what do you suggest from your point of view to the marketeers, to the people who are in the field of management? What calculations? See, we can't calculate everything what you have shown to us, but we can definitely understand the gravity, and we can start from the very scratch that, okay, fine, these are the things where the carbon credit would be quite high, and these are the things where carbon credit would be a bit low. So we can do our calculation and we can come up with the digital campaigns.
Okay, so quantitative measures around sustainability frameworks for this are still being made in the European Union. I know of the committees that are doing this, and it is largely very, it's dependent on the kind of industry that you're working for. So, for instance, it's much easier in aviation, where you just have to do carbon emission check, right? So it's pretty simplistic. It's straightforward. If you can, and I think that's integrated with most air travel websites, right? You can now see that the carbon emission for this flight is going to be a green or an orange. So with some industries, with some cases, it's pretty straightforward. However, I think for most companies, it's an overall measure of carbon emissions, an overall measure of what is the level of, what's the level of sustainability measure that they would like to implement for themselves. However, we're still looking at things like travel. Travel is included in every sort of for our research projects, we do that. We do an evaluation of how sustainable or how eco-friendly or how on the scale of UNSDG goals, where do you rank your particular research proposal, how sustainable it is. So if you look at all of these kind of metrics around whether your travel is sustainable, whether if you're putting something on the social media, if it's a social media campaign, purely social media campaign, I hear so many companies use AI so conveniently to do their campaigns these days. I think it's much more convenient now. But the use of AI has its own set of sustainability issues behind it. So that's something that needs to be cut down. AI is very convenient. It's very useful, but it should be used in the right way. So I think ethics of using AI is for another session, which you can probably plan. But use of AI needs to be curtailed in terms of the number of queries you're making. Plus, if you are asking for any responses from the users, and that's going into a feedback, that also has considerable computing, repercussions onto the system. So bringing all sort of, and I'll talk to you in a very foundational computer science perspective, that save the data that you need to save. Don't save extra data. Use or process the data that you need to process. Don't process extra data. So reduce the number of comparisons, reduce the number of data points, and that should actually be the bottom line for most social media campaigns. Which I think a lot of countries have put a tab on. So for example, GDPR does that in the European Union. So you have to justify.
All right. So, so it again goes back to a sustainability paradox that you discussed.
Yeah,
So, but yeah, I think we can relate with both the things, how exactly we can connect with the practices and the policies that could be brought in, and here the policymakers, come up with a very important role.
I have a question, Dr. Arif, if you may.
Sir, most likely I was just waiting for some crucial person, some other experts from the other field. Yeah, Dr. Matlub Hassan sir, please go ahead.
Ma'am, it's a very good, engaging lecture, actually. I would like to thank you. I just wanted to know a few things like why we are so much of deliberating on things like AI and managing sustainability, when actually, if we see to it, the fact is the carbon that is being emitted into the atmosphere, it is mostly produced by the more traditional industries. Still,
there are have higher carbon emission, not the whole industry, the specific legs of it. So let's say aviation, for instance, has the highest carbon emission. So we can't shut down aviation just because it's, it's emitting a lot of carbon. We can't shut it down. It's useful for us. We've done it for ourselves, right? So that I think is, reducing carbon emission, bringing it to net zero. So the whole idea that the world agreed on was net zero. They never said bring it to zero. They said net zero.
Net zero.
Yeah.
So from your perspective, like the digital assets that is being utilized these days, mostly, I mean, they are mostly contributing to this whole phenomenon of carbon credits.
They are. How many times do you charge your phone in a day? So every digital asset is contributing. Everyone's got 4 devices on an average. If I look at my own space, everyone's got 4 or 5 devices. Everything's being used 24/7. Nobody shuts down their computer these days. So sustainability the digital assets are contributing significantly, not because of every single device, but because every single device, every person is using 4 devices, and there are millions, billions of people doing that. So that is, I think, if cumulatively we look at it, then it's contributing to a lot of sustainability issues.
Oh, thanks, Miss.
So any other query or? All right, so I think this is it. These are the questions.
All right, thank you. I hope it made sense.
Yeah, I'm sure it does. And with this, I would like to invite Ms. Fazi once again.
So on the behalf of the entire organizing team, I'm extended to sincere gratitude to Dr. Samia Khan for gracing this session with her presence and for sharing her valuable insights with us. We are especially grateful to you, ma'am, for joining us ahead of your scheduled time and saving the day. We sincerely appreciate your graciousness and punctuality. We truly appreciate your flexibility and support, especially given the last-minute change due to the previous expert's medical situation. Thank you for sharing your insights and for giving us the privilege of learning from your remarkable academic and research experiences. Your presence has made immense value to this session, and we are deeply grateful. I would also like to thank all the faculty members and participants for their presence and engagement. Thank you once again, Dr. Samia Khan, and everyone for being a part of this session.
Thank you so much. Thank you for the invitation.
Thank you.
Thank you.
Thank you. Thank you once again.
Thanks.
All right, participants and dear colleagues, thank you for being in the session. I'll simply just update you in a short while about the upcoming session over WhatsApp, and the new link will be shared with you in due course of time. Thank you. You can log off from here, and those who have not marked their attendance and feedback, they can do it from the chat box. It was shared and by Dr. Swati, and feedback form as well, both of it. Please do it before leaving this room. Thank you.